Hi everyone, today we'll show you how to make an inverter. An inverter provides power to objects working on alternating current with only a 12-volt battery. First, we'll test our inverter on different devices, then we'll show you how to create yours. Let's start with a simple test. We plug the terminals on the 12-volt battery and then we switch on the inverter. The bulb, which normally works on 230V AC and consumes 25 watts, is now working as if it was plugged on the power outlet. Instead of using high consumption light bulbs, we can use economic ones. Here's a test with 36 watts. And as you see, it works perfectly. Here is another test with our inverter. We will recharge at the same time an iPhone, an iPod and an iPad. When we switch on, there is enough energy remaining to light up a bulb. The inverter is compatible with every switching mode power supply, even the most powerful ones. Now we'll try to supply a stereo. I turn up the volume gradually. So obviously we can't reach the volume's maximum because the inverter can give only up to approximately 30 watts, while the stereo reaches 230 watts when on max. There's blackout. With the inverter we can supply energy to your room's lamp. The soldering irons cable is too small. With the inverter, cables are never too small. Our inverter is made of 3 parts. We have a 50Hz oscillator, 2 MOSFET transistors that amplify the signals, and a transformer. We first have to make the oscillator, which can be considered as an integral component. The positive terminal is placed in the upper position, while the negative one is in the lower. On the sides, it supplies a positive current on one side and 0 for the other, and vice versa, with the frequency that we wish. To have a 50 or 60 Hz frequency, the mains frequency, we will give the specifications of the capacitors and resistors that we use at the end of the video. It consumes 13 mA under 12 volts. A transistor can be considered as an amplifier with 3 terminals: the base, collector and emitter. For an ordinary bipolar transistor, when there is a small current between the base and the emitter, a much powerful current can flow between the collector and the emitter. For example, the tiny current that flows through this resistor would have never been able to light the bulb, but thanks to the transistor, the signal I'm doing can be reproduced in the bulb. In our inverter we use MOSFET transistors. They act like other transistors, except that their terminals are called gate, drain and source. To activate the current between D and S, we just have to apply a voltage more than approximately a 4-volt threshold. As you can see, the current that can flow through the body is enough to activate the MOSFET transistor. We use MOSFET transistors for our inverter because they do not need the current to be activated, which doesn't affect the oscillators working. Since we use recycled components only, the MOSFETs, even from different objects, have relatively the same specifications. This is important because the transistors have to be in perfect sync. They should be neither any dead time nor a time where both transistors are activated. We connect the 2 sides of the oscillator to the transistor's gate terminal. Each 100th of a second, the activated transistor changes. The transformer must have a 1:20 ratio, so we can go from 12 to 230 volts. The ratio must be twice less to reach 110 volts. Since the primary coils are in opposite direction, the direction in which the induced current in the secondary coil flows is opposed to the one from either of the primary coils. We have a 230 volt and 50 Hz current, not really sinusoidal but ideal for supplying mains powered devices. A last test but not the least with 24 volts. This way we can have an 85 watt power, tested here with two bulbs, a 25 and a 60 watts fully lit. However, with 24 volts, because of the transformer ratio we can only obtain 230 volts when we consume 85 watts, and less we consume, more the voltage is increasing. It can go up to 500 volts on open circuit. The circuit consumes 500 mA open and up to 7 amps in short circuit of the outlet. This is why we use a big lead battery, so we can have a range of several hours. We have, for example, a range of 5 hours and a half with this 10 watt bulb. Just for joke, we can also supply a 230 volt laptop stereo with only two 9 volt batteries. I switch it on, and it works!